Okay, whenever I'm recording, there should be a blue light. Is there a blue light?
Yep.
Great. Hopefully we are good to go then, and we're picking up sound. So we left off with H. We're at I. Is that correct?
Yep.
So let's just work through some of these pieces together. How would you begin evaluating that? What would you do first? Okay, so you would do the 1/3 to the third or the 6 squared? How do you do 1/3 to the third? Yeah, you would take 1/3 times 1/3 times 1/3. Or in other words, you take 1 to the third power, which is 1, and you would take 3 to the third power, which is 27, okay, times 6 squared, which is 36. Okay, need to be able to express those numbers as over 1. We multiply, we get 36 over 27. Both are divisible by 9 4/3. What a beautiful number it is. How would you begin doing letter J? You pull a 9? Good, excellent. There's 2 ways of doing it. You guys have seen one way. I'll show you that 5 times 45 is 225, and the square root of 225 is 15. I'll work on that. So let's do your way, which I think is a great way because a lot of people didn't multiply. You didn't see that 5 times 45 is 225. So if you multiply, and you say square root of 5 times square root of 5 times square root of 9. You rewrote that 45 as 5 times 9. Now this becomes pretty simple. What is the root of 5 times the root of 5? It is 5. And what is the root of 9? 3, and you multiply those and you get 15. So 2 ways of doing the problem. Try to do letter K just like I did. Go. The second one. Yeah. Three, 3, and 16. And so the root of 3 times the root of 3 is 3. And then the root of 16 is 4. So I get 12. We good? Okay. Letter L, what would you do first in that situation? Okay, you'd move the negative. So 2 to the negative third, I'd have 2 to the third in the denominator. Whoops, that's a really bad 3, huh? We'll go 2 to the third. And then in the top would be 4 squared. So it looks like you like to get rid of negatives first, which is just fine. So on the top, I have 4 squared, which is 16. And on the bottom, I have 2 to the third, which is 8. And 16 over 8 gives me, yes, dos, which is Spanish for 2. I'm very good at Spanish. Your mom used to teach Spanish. Oh, good days. Good times. We used to eat lunch together all the time. I got a funny story about that I'll have to share with you at one point. All right, square root of 18 minus square root of 200. Let's get to some more challenging problems, okay? Can I subtract those as they are? No. So what do I do? Okay, good. I hear people saying to take out a root, like a root of 9, and then 200 would be good. Okay, so I have the root of 9, which is 3 roots of 2 minus 10 roots of 2. And in that situation, I come up with what? I just can't help myself, okay? So can I show you how to check your answer? So if I'm on the test and I'm like, okay, I've got 15 minutes left, what do I do to check my answer? Well, on your calculator, if you just type the square root of 18 and you subtract the square root of 200, you get negative 9.899. And so if you try then this, negative 7 second root of 2, hopefully we come up with the same result, which we do, right? So that's not the only way to check your answer. There are many ways. Now, if you write an answer of negative 9.899, I give you 0 points for that. Okay? I mean, this is what I want to see. I'm trying to show you how you can confirm your result. I mean, that's really the biggest difference between people who are scoring 18, 19, 20 on the ACT and people who are scoring 28, 29, 30, 31 on the ACT. Those who are able to check their answers quickly. So I'm just trying to help you see that. So what's different about letter B? Cubed root. Can somebody give me a perfect cube? Excellent try. Let's try again. We got 1, 8, 27. Some other numbers. Good. Yeah, you got them all. Yeah, nice. Some other numbers. I love that. All right. Good job. Don't feel bad about throwing out answers that are wrong. My last math class was full of teachers. It was an advanced number theory course. I would say at least 50% of the time we put out an answer was wrong. Okay. Totally confused, way off the wall, didn't know what we were doing, but we tried. So, good. So we've got some of that. So what's the perfect cube that divides evenly into 16? So I've got the cube root of 8 times the cube root of 2 plus, and then this 2 is just hanging out there. What's the perfect cube that divides evenly into 250? So I've got the cube root of 125, and then I've got the cube root of 2. Great. So we all see that that cube root of 2 is obviously very important to us being able to simplify the expression. Agreed? So in this step, the cube root of 8 is 2 cube roots of 2. Make sure that 3 stays in kind of that root portion so I understand what it is. Plus, the cube root of 125 is 5 times 2 is 10 cube roots of 2. And so 2 cube roots of 2 and 10 cube roots of 2 make 12 cube roots of 2. Does your calculator have a cube root button? Yeah, if I just press math, you can see cube root option right there. So, we're just going to, okay, you go away. All right. Yeah, okay, gone. All right, you try C and D on your own. C and D, go. You try. If it's your birthday, you don't have to do one of them.
What? Really?
Just joking, just trying to have fun. You guys are my class that has the highest participation so far of the day. My other classes are a little bit more quiet. 7th hour, that helps. 7th hour does help. Gonna give another 30 seconds. Five, four, three, two, one. Letter C, what do you have? Nice job. Okay. Letter D, there are 2 ways of going about this. My guess is everybody moved the negatives first, right?
Yeah.
So if I could show you, Kenny had the way that I like to do. He said when you're dividing, you subtract. So a to the negative 5 and a to the 8th. So negative 5 minus 8 is negative 13. Agreed? And then he has b to the negative 3rd and b to the negative 7. So negative 3 minus negative 7 is positive 4. So that means the 13 will drop to the denominator and the b to the 4th will stay in the numerator. Now, many people move them ahead of time. That's fine, but keeping in mind the principle of subtraction is also okay. And that's how I prefer to do the problem. So it was neat to see somebody do that. So that's what you come up with. Any questions there? Okay, so you guys understand that on your test, I'm not going to give you n to the 4th times n to the 7th. That's not like going to be one of the problems, right? That was for Miss Kruger's class, right? Like you're going to get something more like that. So let's start with like, where are you going to begin there? Like, where do you want to start with that problem? Let's start here, as you guys kind of direct me. Do I distribute the 3? Does the 3 distribute to each of those? What do you think? You say no? I thought when I saw parentheses, I would distribute. If it was 3 times x plus y, do I distribute there? Because it's addition, right? There's no addition to be distributed over. You get my point? Like if you have 3 times 4 times 5, you don't take 3 times the 4 and 3 times the 5, do you? Okay, so understand what the algebraic expression is asking you to do. So knowing that, we have all of these numbers up there. Which one do you start with? The exponent right here, this cube, right? Let's do that. So I've got 3xy to the 4th times something. So what is that something? What do I do with the 2? 2 times 3 is 6?
No, 8.
2 times 3 is 8? It's kind of fun to hear, wasn't it? It's like 2 times 3 is 8. Yeah, 2 to the 3rd is 8. Good. So I get 8x to the 12, y to the 9th. Good. So now I have 2 expressions that can be multiplied together. The 3 times the 8 gives me 24. How about the x's? What do I do the exponents? 0 plus 12 is 12. Oh, if it's not written there, it's a 1. So I definitely have a 13, and I have y of 13th as well. Good. Excellent. So then letter F, we have a similar situation. It's just dividing. Which part of this are you going to deal with first? Why are you going to flip it? Because this doesn't have a negative on it, so why would I flip it? I get moving this. Why are you going to flip everything? Because of this negative. So you're going to use up that negative right away. Great idea. So we have 2x to the negative 3rd, y to the 4th. In the denominator, x cubed, y to the 3rd. That is all being raised now to the 2nd power. So I've used up that negative. Now what are you going to do? You want to deal with that negative and move it to the bottom. Okay, I like that idea. So you're going to take this guy right here, and you're going to move it to the bottom. So it'll be an x to the 3rd times x to the 3rd, which is x to the 6th. We all okay with that? So I'm going to have a 2y to the 4th in top, and the bottom I'll have an x to the 6th, y to the 3rd, and that's all being squared. So the mistake that you make on the test is you forget to write the squared down again. You know what I mean? Or you forget a negative or something like that. So try to keep it straight. All right, what do I get in the top? 2y to the 4th squared. 4y to the 8th. Excellent. Power to power, we will multiply. And in the denominator? All right, am I done? Now I got to deal with the y's, so we get 4y squared over x to the 12th. Excellent. Good job. You guys are smart. You stop downstairs, thank Miss Hanson, say thank you for making us super smart. Buy her an apple. Actually, she really likes Mountain Dew, so buy her Mountain Dew. Okay, let's just kind of have a come to reality moment here. The fact is, when we see fractions, our brain starts to go to poo, right? I mean, let's just admit, right? And you kind of forget like rules. Like all of a sudden, you see fraction, cross multiply, common denominators, cancel, right? Like those are the things that come to mind. So when you don't know what to do, make an easier problem. Here's what I mean. If this was negative 2a to the 7th times 5a to the 9th, you wouldn't hesitate. You would say that that's negative 10a to the 16th. Agreed? So what that tells you is that you added your exponents. So therefore, we will add our exponents. Get the idea? So negative 2 times 5 is negative 10, a to the, and now we need to add our exponents. So 3/4 plus 3 halves. How do I take 3/4 plus 3 halves? Okay, so you're going to create common denominators by multiplying top and bottom by 2. So 3/4 plus 6/4. What is 3/4 plus 6/4? 9/4. Sweet. Oh, excellent. Thank you for bringing that up. Okay. No, you were fine to leave it like this, but you could write it like this. Negative 10 times the 4th root of a to the 9th. So this bottom number means the root, and the top number means the power. You see that? So I just prefer you to probably leave it like that, but if you did want it right like that, that would be accepted. Yes? Negative. Negative. So I would, yeah, they won't try to trick you like that. They get in big trouble when they try stuff like that. So they try to make the answer clear. What was that? Oh, the negative sign? Yeah, exactly. Those silly ACT people. Nope. All right, letter H. Again, you see fractions, and you say to yourself, oh my goodness, fractions, my brain is going to explode, right? So make the problem easier. If it was 4x to the 6th, y to the 8th, and you were going to take that to the 3rd power, well, that's no big deal, is it? What do you do the exponents? You multiply. So let's multiply the exponents. We'll get to the 4 in a second. We'll get to the 4 in a second, okay? Let's multiply the exponents. So 6 times 3 halves. If you don't know how to do 6 times 3 halves, the number in the top is what you multiply by, and the number in the bottom is what you divide by. So 6 times 3 is, divided by 2 is 9. So you get x to the 9th. And then we have 8 times 3 halves. So you multiply by the top, you divide by the bottom, you get 12. Yes, excellent. It's really close to 14. Good. And then out front, you have 4 to the 3 halves. Let's think about 4 to the 3 halves. And we're going to use your idea about this whole, like, rewrite the radical thing. This is 4 to the 3rd power, and the 2 means the square root of it. That's what that means. Okay? Those two are equivalent. Yes? And so what's 4 to the 3rd? Square root? 8. You try letter I on your own. Go.
I got one of those out like all this. So when we cancel the 4, this become a 2, and then cancel all this. When I get 6.
Yeah, it's not 4 times 3 halves. It's 4 raised to the 3 halves.
Unlike these ones.
Right. The exponents, it's multiplying. So you got to take negative 2 to the 4th. So negative 2 times negative 2 times negative 2 times negative 2.
What the heck is 2?
So negative 2 times negative, yep, 16. And then now you have powers to power. And when you have powers to power, we just multiply. So what's 4 times 1/3? 4/3. Okay, pause where you're at. I got to start with the negative 2. Negative 2 times negative 2 is 4. Times negative 2 is negative 8. Times negative 2 is 16. Great, so I took care of the negative 2. Now, what do you do if you have a power to a power? You multiply. What's 1/3 times 4? 4/3. It is. That's okay. Good eye. Good eye. Okay. Yep. Some people will drop the negative 2 to the denominator because they say it's negative, but that's not an exponent, is it? So it stays up there. Okay. And then what's 1/2 times 4? 2. So it's y squared. And then what's 1/6 times 4? 2/3. Can't do anything else, can we? I mean, if it was an x down here, then we could simplify, right? But it's not. Okay. Okay, last little bit here. We got to simplify radicals if you have algebraic expressions that sit within them. Is a to the 4th a perfect square? So I can put the a to the fourth here. Is b to the seventh a perfect square? No. B to the sixth is though, so then yeah, so these two expressions must multiply to the a to the fourth times b to the seventh. Okay? Good. So square root of that guy is? Good. And then we just attach on that root of b, and that's our answer. Some of you have immaculate handwriting. Great. Some of you struggle in the handwriting department, and this 3 can float all over the place. Like, I don't know if you're writing a squared b times 3 roots of b, or some of you guys have a squared b and then the cubed root of b. Try to, make it look reasonable. And I'm pretty forgiving overall when I see your work on the test, but just please try. Okay, cubed root. Is x to the fourth a perfect cube? What is? Yeah, x to the third. So I got to drop an x over there. Is y to the eighth a perfect cube? Y to the seventh? Y to the sixth. So I have a y to the sixth here. What do I put over there? Y squared. What is the cubed root of x to the third, y to the sixth? And then cubed root of what I have remaining, xy squared. It's kind of fun to write. What would you do for letter C? I hear two options. I hear one option that you could try to start by separating them a little, but I also hear another option. What if we just tried combining them together and then separating? So w times w to the fifth is w to the sixth. I'm going to have v to the 12th. Well, is that a perfect square? Yes. So now I've got w to the third, v to the sixth. And that's that. Okay, thank you for your attention and working through the notes. I do want to bring your attention to this sheet right here. So Kenny is currently working on some of the radicals and some of the exponents. I want you to know that as you work through this, it would be very normal if 90% of you had, say, 3 problems that you struggled with. Okay? I don't expect you to come back tomorrow and be able to say, oh, I got the whole thing done and it was super easy. Please come back and we try 2 to 3 problems at the beginning of class tomorrow that you struggled with. Okay, I have the answer key posted, but as you look at it, if you made a mistake or you got to get help, let's start tomorrow right away. So since you got 1 over 4 to the negative 2, that's the same as 4 over 1 squared. So see how I use up the negative? Yeah. Yep. Sir.
This one here, so I, move the negatives down, but
Good.
That's all we do.
Yep.
All different.
Good.
And then for this one here. So is this being connected to that?
Yeah, kind of, yeah. I mean, this is the same thing as 1/3 b to the 6th.
I can actually these two
Yep.
So that'd be 1/3 b to the 6th.
Yep.
And then this now being times by
12.
Actually, no, the 12 would be on the bottom, actually.
The 12 isn't on the bottom.
Oh, no, wait, the b to the...
Good. Yes. Yep. 4 b to the 6th over b to the 8th. Good. And so then 4 over b squared. Good. You got it.
Elise said that the sound still isn't working in that one.
And it won't, but the sound will work today. So what I did today, as I post this, today's will work, but the other one,
Okay.
no bueno.
Can you post the 1.1%?
It should be, maybe try her to tell her to check her, or to refresh her screen. If I check this right here, whoop, it looks like, oh, this answer key. Got it. I will do so. Thank you. Oh, so this answer key is just tied right there. It's the same thing. So as I click on this guy right here, it has the 1.1 and the 1.2. I'll just delete that other one. Better? Maybe she'll join us tomorrow. That's why she's in first hour now. First hour, seventh hour, first hour. Got it. Have a good day, everybody. Hi.
So, okay, so you can multiply to.
Yes,
have-
exactly.
You just can't add to it. Like
Exactly.
Okay.
Yep.
And then, so parentheses means, so when you're like, so if it's like -2 to the power of 2, if it's in parentheses, then it would be positive.
Yeah, very good. So if I have this expression, if I would have, say, -3 squared, that is -9, whereas -3 quantity squared means -3 times -3, and that would be positive 9. Yep. And that's why we begin the year with a 2-week review. And then from there, hopefully, we can kind of push towards newer content. No problem. Thank you for asking. Dr. Lang, you are teaching 8th grade English this semester. How many sections? 2. And who are you that are teaching it? You know?
Angie, Philip Parker, Aaron, Bradley, and Tess Dowdy.
Okay. All right. What would, so I avoid a talk note. Not this week, but next week, Thursday.
Sounds good to me.
Be okay? If they were to come in, some might be able to feel like they would lead an activity for 25 minutes, and others might feel like they could lead it for 40 minutes, depending on the nature of the group. Do you guys typically, the last day of the week, we've seen a lot of 8th grade teachers do a silent, sustained reading time.
I know. Oh, I should. It's Jen Henschel also.
Okay.
When you said that, that reminded me of Jen. So Jen is definitely doing that.
Okay.
I am doing some, but that's flexible and that can happen whenever.
So if we had a group that used 25 and a group that used 40, teachers would be flexible.
Yeah.
That wouldn't be a problem?
I don't think it would.
Okay.
It would not be a problem for me.
Okay.
Test's first year, well,
Yep.
second year, but first year.
Got it.
So we get to get her, and,
Okay.
we can help talk with her about plans for that if needed.
Very good. Then we'll try it, and we would have the link leaders just do kind of a get-to-know-you activity. We call it interrogation, where you've seen that, is there like a wedding or like a marriage contest where like you see if like one spouse's answers match the other spouse's answers? Do you know what I mean? Newlywed game, yeah. So group of like say 6 kids, and they ask many questions about one kid within a given topic, so food or after school activities, whatever. Yep.
Most popular question on that.
No, I just heard the
It
reference.
was on in the late 70s, early years. It's formative of my early youth.
So then the kid comes up front, like the group of kids, one from each group that was being interrogated, and then they ask questions, and as they write it down, we see if the answer of the group matches with what they have. But it's a way for the 8th graders to, I guess, experience something with the link leaders, and a way for the link leaders to kind of start to just refine some of their facilitating and group management skills before they try something that might be a little bit more, of a risk. So thank you. I'll send out an email shortly.
Anyone object, you can blame me.